1, 2, 3. Hello. I think a lot of people have talked with a few of you around the 3D printer on the back side, and we'll be talking about that cool stuff, the gadgets and some crazy stuff. We're actually going to talk about code, yes, but code with some other interesting stuff. I'm going to talk about Arduino circuit boards and 3D printers. Well, let's start with the Arduino. What's Arduino? Why am I talking about Arduino? What is this? Well, actually, Arduino is a circuit board that you can buy by like 20 pounds on eBay. Very cheap, easy, simple. Is it a computer? No, it's not a computer. It's a circuit board that it's very simple. You can't connect monitors, keyboards, download softwares. No, it's not actually like that. But it's actually not a Raspberry Pi. I don't know if anyone here knows Raspberry Pi. Raspberry Pi is a very simple, fantastic computer that is the size of a credit card, but it's actually a computer, the Raspberry Pi. Yes, you can connect a lot of stuff. You can also run a 3D printer with Arduino, with Raspberry Pi. But Raspberry Pi is something more advanced. Arduino is something that was intended to help people to learn about electronics. So it's something simpler and, well, energy efficient and cheaper. Do I need to learn C++? Why I'm talking about that? Because if anyone here had any contact with programmable chips, you know that you need to go to a very low level code. No, that's the advantage of Arduino. Arduino is very simple. Where did that come from? From Italy, actually. Hello, people from Italy. Arduino is your brother. Some people created that with the intention to help people to learn about electronics. And can it make me a drink? My presentation is going to answer that question. OK? That's the Arduino board. It's an open source electronic. It's very simple. It's very basic. It's cheap. You can buy, as I said, you can buy some versions by like 20 pounds on eBay. And it's very easy to use. We have versions. It's not everyone knows the basic one, but we have different flavors based on different needs. OK? Different size, colors. So if you want to build something with Arduino, you need to keep in mind that there's a lot of options. Do some search about the options you have, and you find something that fits in your needs. Yeah, we also have this thing running .NET. I don't know. I placed the question here. Is it good or bad? I don't know. Arduino is very simple. Maybe we don't need that. But actually, I like the approach they have with the NetDuino. That's one of the variations of Arduino, that software meets hardware. I don't know you, but when I started coding, when I started to build stuff on computers, I was amazed with that thing that's like an endless box of Lego. Like, it's endless. Building software. You can do what you want. You just need time and an idea. You can research, you can learn. It's endless. You can do what you want. And these days, your software is not even locked in your computer. You have your software running in your hands, in your mobile, in small screen. Well, not very small, this one, but in small screens. And even around the world, but your software is still locked in a screen. Yeah, it's over the world. It's making, maybe my software is helping people to make real changes in the world, but your software is still locked in a screen. And here, in a very easy way, we start to break the wall that holds your software inside the screen. It's really easy, yes and no. Why is it really easy? If you have a look here, anyone that had any contact with JavaScript can understand this code. I'm basically declaring a variable, placing a number, and call functions. And that's the magic about Arduino. You have functions. And these functions are intended to read information from the real world and write information in the real world. Like this one, I'm just setting that the pin number 13 will be an output, because in Arduino have a lot of pins, the ports. And I'm saying this one will be an output. So I'm going to send information through that port. And here I did a digital write on the LED, that's 13, high, I'll wait 1 second, and then I'm writing an information again. I'm saying low on the same pin. So what I'm doing is 1 pin on the board, I'm having 5 volts, wait 1 second, turn off that 5 volts, wait 1 second. So basically I'm flashing an LED. So this code makes changes in the real world. I'm flashing an LED on my board. But I'm talking here about a simple LED. We can go further with that. It's not just LED. We can have servo motors, light sensors, temperature sensors, buttons. Like here, it's a very simple scheme of a knob that you can control which LED we are going to light. So I'm receiving an information from the real world, a knob, thinking and changing the electricity that's coming from the ports to the LEDs. And it's a very simple one. We can go even further because the Arduino Arduino became a success these days, and we have a lot of stuff. Go to eBay and type Arduino, and you're going to see a lot of stuff. We have LCD panels, so you can have an LCD that you can write messages on the LCD panel. We can have Bluetooth. Yes, you can talk to your board in your cell phone. Even web servers, GPS, GSM. I've seen a guy that they made a doorknob with Arduino, with a motor that can move the knob, and one of these GSM ports that you connect to. See, there's an Arduino board down there, another one top there, and the guy was texting his door to say, open please, close please. It works. It works. It's just sending, his software is just saying, put electricity in one of the ports, and that port is connected to a servo motor, and we are moving a servo motors. And remember the question I asked it before about, can it make me a drink? Have a look on this. The guy is choosing one option and saying yes. And that's the inebriator. And you can see that there's nothing so special. It's one DC motor moving the base, another one moving that piece that pulls the drink, and there's the software in the Arduino board that knows for each drink how much of each one, and that's just numbers, how much you need to turn the DC motor. There's not 2 DC motors, some LEDs, an Arduino board. There's nothing. With the Arduino, yes. But that is a quite complex one. This one is quite interesting because it's very simple. Only 3 servo motors and a lot of code. It's drawing the time. Look, we have 1 servo motor here that move up and down, and 2 here moving the arm. It's 3 servo motors and some math. We need to do some math about the number and the path, but that's it. Nothing special. Here's an evolution. The guy put an LCD panel so you can see what is writing and have some information from what's happening in your software in the board. But now, look, coding that will be quite hard to draw the numbers, to have the data about the numbers, but that's it. It's not complex. It's definitely not complex. And let's talk about my project, because I did one project. It's not here today, sorry, but I did one project. And what's my project? Well, that's a record player, a turntable. Yes, it's my record player. I like to listen to my old rock and roll and my records, but this one have a problem. The speed keeps varying. It's very annoying. The music, it's horrible. So what I should do with my turntable that is broken? Throw away or buy a new one. But no, what I did. I noticed that my turntable has this knob that's the pinch. I don't know, there's any DJ here that can tell me? I don't know, I think that's the pitch that people call. Yes, that's right? Yeah, we have one DJ here. Yeah. It's a fine adjustment about the speed. Yeah, we have that push buttons for 33 revolutions per minute, 45 by some very old records. But it's not by this. I'm talking about fine tuning. And what was happening that every 5 minutes I'm going to turntable and moving that. And then the music was crap. Oh my God, 5 minutes, go there, move again. And I was annoyed with that. And then I start to notice some things. I have this metal dots here. And I noticed that if I use what's that here? You know this laser pointers? That's actually a laser pointer, simple laser pointer. The light is that dot can reflect the light. And then I remember that I have a light sensor that's a very cheap. It's like 50p, even less if you buy in the big pack. It's a light sensor. That's a resistor that changes a number. For Arduino point of view, is a function that you call and you receive a number. That's it. You call a function, receive a number from a door, from a port that the light sensor is connected, and gives a number about the light, how bright is the light. And I noticed that if I point the laser pointer to that, I have a high number. If I turn it off, a lower number. So what I did, I connected my Arduino board to that with the laser pointer. And I start to be able to capture the speed of how long is taking one revolution. I actually need to take 1.8 seconds. I don't know if you can see here. I cover one of them. So what I was having on my Arduino board, a very high number, because the laser was reaching the light sensor. And then when that cover one was passing by, I had a drop. So for each revolution, I have a drop in that number from the light sensor. So I can measure the time of this taking one revolution. So what I did, I attached a servo motor to move the pinch. So it can adjust by itself. It measures the speed. If the speed is too high, move down. It's too low, move up. And what we have here is my turntable working. That's my Arduino board. Connected that. See, it's a laser pointer like this, a 1 pound laser pointer, nothing more. We have the metal dots that reflect the light. See, light sensor, light, no light, light, no light. Come off? Yeah, no light. And I can capture that on the Arduino. So I was able to measure the speed. And we can capture, because the Arduino, you talk to your Arduino board, even when it's running through serial communication. So during the execution, you can even get the numbers. And see, it will move. My turntable can adjust itself. And you know what's magic about, see the numbers? It is executing and giving me information. I can also type and send serial values. But for me, the magic here, I'm not showing here in the video, the magic here is when you pull the cable, the serial cable, and leave it there. Like you create something, it was connected to your computer, I wrote the software, I placed my software on that board, and pull the cable. And my software is there, in the real world, working, alive. I built something that works. Well, that's a quick introduction to Arduino. But and about 3D printers. What's the relation between Arduino and 3D printers? Well, as we notice, we write a code, put it on the Arduino board, and something happens in the real world. I can move arms, control stuff, build a robot, a car, something else. But what if, instead of just building something that works, I use my code to put in Arduino and move something that builds something? And that's a 3D printer. Well, as a quick introduction for 3D printers, these days we have options. We have big, famous 3D printers, and the simple ones like mine. And as you can see here, it's Arduino board. My 3D printer uses an Arduino board. What's the difference between these top brands and homemade ones? Well, the first one, of course, it's a huge difference. But And you say, okay, so the obvious choice is that one. Not really. Depends on what you want. Using a very simple, maybe not fair example, this one is just a print button. You have something to print, you press print, that come out. That's it. Nothing to do, no options, nothing. You don't need that. It's smart enough. The softwares that came with the 3D printer are fantastic. So that's why it's so expensive. That one, maybe not fair comparisons to Linux. Everything you do in a Windows, you can do in Linux. But maybe you need to spend more time and understand a little bit more. You need to learn something. You need to do sometimes some things by yourself. Well, sometimes even in Windows, you need to learn. You need to have problems. But we know that working with Linux, you can reach everything, but you need to maybe spend some more time. And that's what happened to my one. So let's do it. As a brief introduction, I want to show you more or less the software behind the 3D print. The 3D print you can see that back here. But I'm going to see you something about 3D printer software. One of the first things you need to know is you don't need to print everything. You can go to internet. We have the Thingiverse site that you can just download. We can go here in my profile, my things I actually did, and look what we have here. It's the T800 head. Why not? It's a 3D model. Actually, from this site, I'm downloading a 3D model that can open 3D Max and stuff. It's just a 3D model, nothing intended to 3D printer. It's a 3D model in your computer. So what I'm going to do with my 3D model, I'm going to use some free software that I have. This one is one I use. It's called the Slicer. So I'm going to take my 3D model. I have my 3D model here. Place here. Let's just see if it is my. Oh, it's on my screen here. Oop, let me show you. Yeah, it's my T800 head. See? Scary, huh? What this software does, it takes a 3D model and transforms that in a text file with instructions how to build that. So you don't need to care about that. You have a 3D model. This software helps you to write the 3D printer instructions. So this software is going to generate a G-code file, .gcode, that's the name. It's actually a text file. I have one here. Let me show you. Come on. It's horrible to work with two screens. You never knows which one. Here, there, here. And that's, see, it's just instructions for the 3D printer, but it's actually a text file. And that school is here. The T800 is here. Okay? After you have that, you can use a different software. Oops. That is basically the slicer creates a plan. And the other software executes the plan. If you go there to my 3D printer, you're going to see this software. I'm going to load here my school. Where's the G-code? G-code terminator, G-code, yes. Open, please. And actually, you can see I'm working on a MacBook. It works. There I have an Ubuntu, Linux. It works. It's quite easy to work with 3D printers. And here what I have, ta-da, prepared to be executed. And if we zoom in, it's only lines. It's the path the 3D printer is going to make. That's it. And that's the school. And then, finally, you can just use the software. That's the software I'm using to send that. Basically, the software is taking that text file, taking row by line, and sending to the 3D printer. The 3D printer is quite dumb. It's not thinking. It's just receiving that line by line and moving the models as it says. It's quite simple. You say it's simple. And after that, that's your final result. Yeah, it's cool. And that's the 3D printer. Everyone is welcome to go to the 3D printer, see what's happening, ask anything, I can help. I'm a hobbyist, I'm not a professional. I am actually a software developer. It's just my hobby. But if I can help you with something, actually I'm playing Guns N' Roses on my turntable with the T800. How cool is that? Sorry?
How long did it take to print this?
This head was like 5 hours. Yeah, the 3D printer, homemade 3D printer, what to expect.
Rodrigo, what is the size of the head? Is it like...
No, it's like 8 centimeters. Yeah, it's very small. Yeah, this size and 5 hours. Homemade 3D printer. Yeah. And the Arduino adjusting the speed. How cool is that, huh? Thank you.